Hello and welcome back to the development of the Feersum scheme compiler. So in today's stream, I want to have a look at finishing off what we started tackling in the last stream, which is to unify the treatment of storage ref built-in and storage ref global. So what that means is that we currently distinguish between imported methods and imported properties. Imported properties being things that we're importing from assemblies that we've generated, and the imported methods being things that have come in from our standard library. But pretty much everything that we need to do with them is actually the same. So we can get rid of those two separate code paths in the compiler, hopefully, and just get down to passing around one bag of things that you might need to import at some point in the future. And that'll clean up the code base a little bit. That should then be the work on libraries and imports done. I'd then like to move on to looking at runtimes. So I'd like to be able to support building with different target frameworks. At the moment, our compiler runs on .NET 5 and the code that we generate can be run on .NET 5, but it'd be nice if we could still run the compiler on .NET 5, but build it using the Mono SDK and then run it using Mono, or build it using the .NET 6 SDK when that comes out and run it on .NET 6. So to be able to support that, we need to make sure that all of the code that we emit is referencing all the code that we emit is only referencing stuff through the mono reflection, which we tackled last time. And then we also need to have some way of passing in what .NET, like MS core lib or system runtime lib or net standard, the like core library from the SDK. We need a way of passing that path in. So we'll have a look at where those libraries live in .NET Core and Mono, and how we can build some abstraction around finding those libraries. And I'd still like it to be that you can run the compiler from the command line and it will just generate something that you can run. So we'll need to abstract away some of the special cases that we've got for generating deps or runtime config files so that assemblies can be run on .NET Core. And we might have a look at running the compiler from an MS build SDK so that we can start looking at how we would define an SDK so that you'd be able to create well, not a CS proj, but like an SCM proj file and put all your scheme files in it and have it built by .NET Build. Let's start by looking over what went on in the last stream though. So most of the work in the last stream was in the built-ins module. So we have this method load core types, which used to import into Lisp assembly, the assembly that we are actually trying to compile and produce. It used to import into that assembly references to the types of methods that we use throughout the compilation. So things like system func that we use to generate our callable things on the stack, and references to the constructors of things like the non-user code attribute, step through attribute that we use to annotate things. So the main change that we did is that we're now passing in this extern assemblies, which is a sequence of mono style assembly definitions. We've got a fudge where we actually load those and pass them in at the moment, and that's one thing we want to tackle with the ability to actually, instead of just doing what we're doing here where we do type of object.assembly, and so we're picking the MS core lib that our compiler is using, it'd be nice if we could pass in that path and load that from somewhere. Then we use these helper methods to generate all of our types rather than calling import reference on .NET reflection style things. So instead of using type of, we're actually looking things up from assemblies by name. There was a bit of awkwardness around how we imported system func object array object, and that I solved off stream. So I ported the Stack Overflow post that we found, make host instance generic, into F#. So this now does what we were expecting it to do. Because effectively, when you look up system func, you don't get there's no type for func object array object. There's actually just like func tick2, which means like a func with 2 generic parameters. And what we have to do is create an instance of that generic type for the parameters, and then we have to do a little bit of hackery to take the method reference we find for the system func tick2, the generic type, and convert it into a method reference on the specific type that we are looking for. So that's what that make host instance generic does, and we use that to create a reference to our func ctor and the func invoke, which are the methods which we actually use from the constructor. Which we actually use from the func type. Everything else is basically just a call to get type, get single ctor, or get ctor by arity, because that's basically what we actually needed. So with that, the only places that we are using type of now is in the built-ins to get the actual locations of our copy of the core libraries, and in the compile where we copy our assembly location like out and put it next to the library. So there's this whole block of code. If diags is empty and output type is exe, now there's a big to do where we're effectively fudging the runtime config JSON. So usually if you do a .NET build, .NET would run .NET build would do some MS build stuff, run the compiler, which generates the output assembly, and then it would also generate next to it a runtime config file, which tells the actual .NET runtime. When you type .NET, your assembly name, it tells the runtime what target framework to use and what target framework you were compiled against, so the runtime knows how to run it. Without this file, you can't run the assemblies. So we generate that. It would be nice to support other target frameworks, and it would be nice to not have to. It would be nice to support not generating that as well, so that we can integrate into MS Build and all of that goodness in the future. But for today, we'll start off in the binder. In the binder, we have this type storage ref. So between streams, I have got rid of the storage ref built in. And now we just have storage ref. Instead of having storage ref built-in and storage ref global, where built-in was an external method that needed to be imported, and global was an external or built-in field where we need to import the foreign properties or fields. We've now just got this single global. So we've got the type name and global type now is either method or field. And then when we emit loads and stores, we do a switch over them, well, we do a match, and in fact, we can find all references and go and have a look. We want to have a look at that one, don't we? In compile, when we do a write to or a read from, we go, if it's a global, look at the whether or not it's a method or a field. So if it's a method, we look it up from the built-ins table, and if it is a field, we call ensure field. So this is the code path that I want to try and unify, because what we've effectively got is this core built-ins, which is a dictionary, or it's a map, which can be used to look up the method reference that we need to import ref, and the code in ensure field, which tries to find the type, and if it finds the type, it calls import reference. And what's happening here is that the type could be a type from another module. This type, which we look up from context libraries, could be injected. So context libraries starts out in the emit as externs with the program type added in, and then every time we find another library, we add one in. So like if you've done a define library form, we'll add it into that list. But what we've got here is this map of string to type definition for the external types, which can be used as libraries. And then we've also got built-ins. Built-ins comes from core, so we call built-ins import core, and in here we do load external built-ins, which looks through the same like Serifa assemblies, finds the types, and finds anything that's exported from it. So anything that's marked with the Lisp library attribute, and then adds all of the methods into a dictionary. So I guess a good place to start here is to have a look at where we generate those built-ins initially, I think. But I said plummet. This is pretty complex. I guess so. Any software ends up being complex if you are unfamiliar with it, though. At the end of the day, once you understand the problem, it'll probably end up reducing down to just building up some data structures, some maps, some lists, and then iterating through them, and just like all of the software problems. So what we want to try and find out here is, how do we build up that map for the externs? So we've got load core types, import core called load external built-ins. I wonder if we could just, so this is going through the all of the types in the external assembly. So the external assembly in this case being our standard library. and it calls this tricata type, which is just a terrible name for a function, but we use this from two places. Once when we're loading the built-ins, and once when we are trying to get the signature. So this is when we're actually load this. Oh, this is when we're loading the library signature, which is the thing that we pass into the binder so that the binder knows what methods there are. And then there's this load core signature that produces the signature for all of the libraries. Yeah, this produces the signature of all the libraries that we have in the standard library. And this is when someone's passed dash reference on the command line. So this is doing something a little bit special because we load all of the signatures and we end up with the types that each library comes from. Then we add the macros on. That was an accident. Yeah, so then we add the macros on and group them by library name. So we're kind of like reconstituting it, because in the code that we generate, when you do something like when you define a library, like in this case we define a library called sort, we will emit a type called sort, and we will put a property on it. Sorry, not a property. We'll put a static field for each one of the things that you define in the library, and if they are exported, we will mark them with an export. And that means that the entire library is contained in a single type. But if we look at something like arithmetics, this is part of the scheme base library, but then so is vectors. No, not that one. Vectors. This one. Which means that the library is actually split across multiple types. And that is why we are doing this aggregation thing here. In fact, some parts of the scheme base library come from this core macro signature as well. So there's not necessarily a unique type for a library. But does it matter? So in compile, we have ref libs, and then we split it out again into the signature and the library signatures and where else do we use reflibs? Interesting, we just pass it straight in to emit. But we just pick the types out this time. So here we produce a map. So we don't actually need these pairs of types to libraries to match up. We could probably get away with just having a look down. I don't think anyone else uses it. So I think the first refactor to make is the reflibs probably wants to become extern ties, maybe. And we can do extern ties. Well, then let's refactor the call site first. So we'll do let ref ties equals, and then we'll just do the same map, but we'll pick the other half of each tuple out. So instead of picking the signature, we'll pick the type. Oh, that's not quite right. And then we can pass ref ties. So we're starting to separate out library signatures from types. So the emit only has to worry about the extern types instead. Then this doesn't need to take a tuple anymore. Does this? See, that knows that that's a sequence, but if I get rid of the type, if I get rid of the hint there, can I just do type? Whoop. No, I can't. So that needs to be type reference. Oh, type definition. So that way we build up our dictionary of like types that might be used for libraries. So this is later on used when someone emits a global. We use that dictionary. We look in that dictionary and look for the property. Sorry, we look for the field if it's a storage ref field. So then down here for reflibs again, we just want that to be extern ties. Then we don't need quite as much tuple. We still I mean, it will have worked out by this point that that is a type, hopefully, because of the hint up there. And then what this is doing is looking for library body. What's this? I'm struggling to work out exactly. Oh, okay. So this is doing... It's doing a find. And then it's mapping that through import reference to get the method reference. This is so that we can find the library body initializer. I wonder if we can get away, because our library won't have, our standard library types won't have a library body because they won't have an initializer. Everything's just done with methods, but the compilation output of the compiler needs those library bodies because we need to initialize the fields. So this probably wants to be a try find, which then means that this needs to be well, how about we rewrite this a little bit? So we do the try find first, and then we end up with an option. Then we can do an option map. Where we get the method and produce a tuple. This might make it a little bit more readable as well. Out of the type name and the method import referenced. And we've even got roughly the right quantity of brackets there. What are you upset about? So this wants to be choose, I believe. So we go through all of our external types. If they do have a library body, then we import reference it. I'm going to run the tests and see if we've broken anything already. Hopefully not. It looks good. Let's stage what we've got then. So emit now takes the extern types instead, and we look up. We produce the extern map, which is the type to, like type name to type lookup, and the initializer map. We produce both of those. I mean, they're both keyed on the same thing here. Are they? They're not. That's keyed on type name, which is just the simple name. So, for example, in here, type name would be vectors, whereas the other one is keyed on full name, which would be Sarifa.vectors. I wonder if we can get rid of that difference. It sounds like it would be better to always use the full name, but I suspect if I just change that, what's going to happen is that we're going to fail some of our tests because we won't emit, when we do an import, we'll be looking it up by something different, by type name. Why will that be? Import, emit, import, kind, it's going to be I think it's somewhere in, oh, this will be in the binder. So in the binder, import, no, that's when we actually import the declarations from. So bind library. Ooh, that's going to be awkward. We don't really know what the full name of the type's going to be here. We could probably work it out, and we probably should know it, but it's this mangled name here. So we're using the mangled name of the library, which is basically just, if your library was scheme based, it's just scheme based with some colons pasted in the middle for the time being. It could get more complex, but that does then end up mapping down to the class name of the library, but not the full path. So I don't think we can unify those two maps. So imports, this does still need to be name, which is unfortunate because we could have had a map where we had both the type definition and the initializer for that type as the value in the same map. But for the time being, that should mean that we can start, like, we should now be able to, when we call compile, when we pass in extern ties, which we do in emit, here, so we've got core libs and ref libs. We've got reference types. We'd be able to have core types as well. So I think what we really want to do is we want load reference signatures to return, instead of at the moment, it returns a list of pairs, we want it to return a pair of lists so that the number of types and the number of libraries could be different. Because I don't think we care, as it stands, if the type is... Like, we don't care that those types match up, because all we're ever doing is picking them apart. And then that would mean that we could include the types from the core library in reference types. Where I'm going here is that would then mean in built-ins, we wouldn't need to put built-ins into our core types anymore. We wouldn't need to load it like this. We'd be able to have it external, and we'd be able to do this import reference later when someone actually emits a call to a built-in method, rather than pre-importing all of the stuff from the standard library. So let's stage what we've got. Use types not plain. Pass referenced types to emit. Don't need to pass library signatures to the emit. All the emitter cares about is looking up properties from referenced types by name. So let's try and follow that through. I think it might be easier to just start off by ripping built-ins out of Do you want to remove it? Go on, let's do that. And then we can just follow through the red squiggles. So built-ins doesn't need to be initialized to empty here, which is kind of also a good thing because it means that I don't need to worry about that. And env decals. Why is add env decals all the way down here? Could we not just do that in here? That's Lisp assembly, isn't it? Idling of the lights. We're joined by a cat again. Brown says, hi, curious what kind of compiler are you writing? I'm writing a compiler for the R7RS scheme, which is the current most up-to-date version of the scheme specification. So this stuff, lots of parentheses. It's a functional programming language, but it does have static scopes so that you can resolve all of these references at compile time. And we're then compiling that down into .NET assemblies so that you can run them on the .NET runtime. Well, that was loud. yeah, add mdacles, we can get rid of that. Then that just needs to be load core types from there. This is starting to look better. I mean, deleting code's always a good thing, right? So why did I do that? I wanted to get rid of this. So I think one of these methods, one of these functions, that's the word, is not needed anymore. Is it load extern built-ins? Yes. And the idea is going to be that we'll look these methods up later on, so we don't need to build up this map anymore. That's fine. And then we want load core signatures and load referenced signatures to return the same thing. Which can we do this with a fold? Probably. So effectively at the moment we're returning a list of pairs and we want to instead return a pair of lists. So the folder is going to, fold takes a folder, which is a function that takes a state and something and returns the new state. It takes a state and it takes a sequence. So we're going to pass in fun state sig, I guess. And we are going to, our state is going to be a pair of empty lists. And the result is then going to be a pair of lists. Do I need a comma there, don't I? So I guess what we're going to do is we're going to produce a pair where the head is, let's destructure here. So we'll say L, which is going to be ties. And the right hand side of the pair is going to be sigs. So this is then going to be, oh wait a second, we take the state first and then we take our new sig, which is going to be tie sig, and then we return what keywords. That's not what we want. And then we'll return T. I've been informed that we're supposed to put spaces around the list comprehension operator because it's an infix operator. You don't just paste two things together, treat it like a plus. But we're learning. Then S and sigs. So now we are returning a list of type definition and a list of signatures, which is good. Which means we can probably put some nominal type definition in for the core macros, can't we? So core macros at the moment produces just the library signature. And it just produces a single library signature. Yeah, let's stop this from being a sequence. We can just hack it. So we've got core macros, and we don't want to group by library name and collect the exports. The whole point is that we are going... yeah. We just want to repack this. Ties, sigs. So if you do that, then we can just we can return the same types, but core macros pasted on the front of the signatures. And then we're returning the same thing in both cases. We're now returning a list of type definitions and a list of storage references. So this means that as far as the built-ins are concerned, types and libraries aren't tied together anymore. The question is, what have we broken and why is it the compiler? I don't see any squiggles in here though, which is potentially worrying. Okay, so we have core libs. Yeah, I think you're a bit confused there. So let's get rid of all of these things. So if we just say that references, we probably want to seek map that, and then we'll end up with a sequence of lists. And then fold the whole thing back down. That's going to be fun. Our state is going to be... It's going to be very close to... It's going to be very, very close to this. So maybe that should be a method of its own. So let public combine signatures sigs is just going to be sigs and then this fold. And then we can pipe that through combine signatures. What went wrong there? Oh, yes. Pasted in the wrong place. We wanted that to be there. So now we've got a type definition list and library signature stuff. Back again. Combine signatures is going to be folds a list of library. References. Then in the compiler, we can do built-ins combine signatures, and then hopefully reflibs to load referenced signatures. Then that becomes do we need to combine that down again? Because we've got one. Oh, because each reference could produce. Yeah, all right, for the time being. Oh, we can't just do that. Because this takes a pair of things and returns a list of the first and a list of the second, which works fine for one level. So then the problem is that this is a sequence of those pairs, and we need to list append them. So I think we need to do our own fold. Oh well. this is going to be a pair of empty lists. And then what we're going to do is this is going to be ties, sigs, and then additional ties and additional sigs. And we want to do this dot append ties, a ties, this dot append sigs, a6. Some squiggles there. Yep. Don't need a comma there. Oh wow. So what do we reckon? That's maybe, what's the type of, so that is now a list of type definition and a list of library signatures. So we can decompose that into ref ties ref ties all libs yeah, capitals. Then core libs just needs to find its way in here somehow. So maybe seek dot concat. Do we have an append? It takes a sequence. What does append do? Takes two sequences. What does, so collect flattens two sequences together, append. So we want to make that a singleton. Built-ins dot load like that. Now this might even compile. Oh yes, I forgot I ripped built-ins out of core types. It's not going to compile at all. So so we've got the types. Do we want to, well, we've got ensure field. I'm wondering if we just want to do the same kind of thing. Let meth equals get extern method, which is going to be it's going to take a, just going to take a context, a type, and an ID. And then let's go find out where ensure field is. Private get extern method context. It's actually type name and ID, even though we called it mangled prefix in the other one. What we're going to do is we're going to do sequence start. we do let type equals batch map try find type name ID. Oh no, we just want to find that in the context libraries. Let's just copy and paste for the time being. We can neaten it up later. Method that needs to be type name. So if we have found a type, we can then find the method. And the predicate is just going to be this fun dot name is equal to the ID that we've given. You don't know that that's a method reference because it's not, it's a field, so that needs to be get methods. So get methods returns only the actual methods. There's also like static methods and constructors and stuff in the dot methods. So that returns an enumerable method definition. We can do this as a pipeline that might help. So I don't have to write any type annotations. It does, and then we can do map method main module import reference that method, and that doesn't want to be an option. Do we want to do try find? Because down here in ensure field, we have the backup of being able to add the fields to the type, which I think we want to rip out at some point in the really imminent future. So I don't know if we want to just do like this. Let method equals, and then just find the method and then return import the method. That way, down here, we do get extern method, which is a method reference. I think we should be good. There's quite a bit of shared code there between how we import a field and a method. So it's probably something that we can tidy up a little bit. Let's see how the tests get on. Well, that's interesting. Undefined symbol. So somehow or other, we aren't properly importing the core library anymore. So let's get the debugger open. I've just been distracted by the fact that this bar has appeared for some reason. Okay, right. So now it gets okay. So we don't want to run the REPL. We want to run the compiler, please. We want to do spec q sort cm because it's my fave right now. It's relatively short, and I seem to be able to reliably type it, which is quite key. So that's done some stuff. What did we want to do? Oh yeah, we don't actually have any breakpoints anywhere useful. So back down to the public. We want to have a look at what goes on here in compile. But also we want to have a look. We do some binding. Yeah, so we do the bind here in compile. So let's do spec q sort. Reference types. Oh, libs. Oh, I know exactly what's happened. That's so right. Brace yourself. Yeah, we have more than one scheme base, and our excellent library resolution algorithm just, well, I mean, it's list.find, which is gonna return the first one. So if you happen to be using whatever this exports, which is it's just the macros, then you're good. Otherwise you're not good. So core signatures needs to do a little bit more, because core signatures needs to be core macros and core signatures, which is going to be sigs. So let's do this. Core macros and signatures, and then we want to flatten them. Group by group by library name. And what did we used to do here? Did you used to do seek.map and then list of seek? I think we must have done. So that's going to be the name and the sigs. Cat's upset, but not necessarily wanting to go outside. So the library name and then exports, which was going to be list dot collect all of the exports from SIGs. Maybe. Does that need to be seek.collect? But then that's not a list. And then this is not a list either. Go outside. We could probably break out of the debugger now. Just run the tests. Sure they're all going to pass. Sure no mistakes were made. Of seek is not. Are you sure? Ah, no, you're right. You were right, compiler. Let's make sure it works. By which I mean make sure it builds and then run the tests. And that's probably the right way around. Don't know if that's fewer failures or not. Different failures. An index specifying. So, well, we know libcapture fails. We know qsort fails. Qsort. Let's find out where we end up throwing an exception. This is so all libraries looks correct. Probably correct. So it's a global from serif right, because I suspect one of these is going to somehow or other not be correct. Let's just let it run until it explodes. Method. Key not found exception. Fair enough. So we've got the methods. What are the methods then? Running the results for you. Yeah, well, that's what we want to do. So we've got like car and cadet, and what are we looking for? Well, that explains it. Get extern method. So so the problem here is that the get extern method is being passed in the Lisp name. So it's being passed in the correct type name, and we're finding the type, but this ID is wrong. And that's because somewhere in here we must load the method. We must put the wrong thing in. So we've got on global and on built-in, which we're passing through here. We're giving the full name of the type, but get exports passes in type and then field name. This passes in the method name. No, it doesn't. It passes in name. So this needs to be method tie name math. I'm passing name. Fingers crossed. I mean, I don't have my fingers crossed, but you never know. Just saying it might be enough. Not bad. So, as soon as that works, let's go over what we've done and stage it. So we've ripped built-ins out of core types. We have properly put the method name into get exports. We've inlined add environment declarations just so that we don't have to redo it later on in the load core types. We've got this new combine signatures, which we actually didn't end up needing publicly, I think. So we can probably just make that private method. Looks like it. So we now, basically all of this stuff is changing load reference signatures to, instead of returning a list of pairs, to return a pair of lists, so that the number of types and the number of library signatures that we return could be different. And that's so that we can support the R core assembly where we've got more than one type that's part of the same library. And then that means that load core types doesn't produce the built-ins anymore. We just rely on the fact that load core signatures now returns instead of returning a list of library signatures, it returns a list of type definition and library signature. Then over in the compiler, we've now got this get extern method, which looks up from the same type cache as the ensure field. We call get extern method instead of directly indexing into the core built-ins, and then we've got a little bit of change to how we compute the reference types and reference libraries when we call compile. So instead of us having to pick apart the two separate lists, instead we just append the built-ins for the core and all of the references that we managed to load, and then group them all together into one big pair of lists. The rest of it is okay. So unify global what is this? Methods and properties. Global methods and property references are now resolved from the same cache types. So in the compiler, what can we do to unify this ensure field and what it might be nice to do is separate out the type definitions that we've produced from the type definitions that are external. So maybe we have an exports or externs, which is a map of string to type definition. We still have the libraries being the same thing. Then down when we create the root emit context, we have our externs and pass them in as a separate thing. That wants to be map.empty. So we start off with a single library in our mutable dictionary of libraries, but we have all of the externs baked in here. That means that when we call find extern or get extern method, we don't want to look in. We can have let we can have get extern type, which takes a context and a type name. we can then move this in there. But instead of looking at context libraries, we look at context externs. Attempt to access external type, which is not imported. There's definitely an internal compiler error. We shouldn't ever omit that. We should have, because we'll only be calling this if we've bound it, and if we bound it, we should have the type. So then down here, for getExtern method, we can make this be let tie equals get extern type context type name. So this is find a given extern type. Where I'm heading with this is, I wonder if we can just get rid of we do need to know the difference between a method and a property, because the way we handle them is going to be different. Because for a property, we can just do a load. For a method, we have to wrap it. For the time being. I mean, it would be nice to be able to cache those funcs as well, so we don't, like, every single time you call display, we don't new up a new func, but that is a problem for another day. Find an extern type by name. Let's say full, so that it's obvious we're supposed to be using the proper full type name. And this can be just the match. Find method. So then we've got ensure field. Which, I mean, how many times is this called? Because it's called once in write to and once in read from. I'm going to call it get field. Just so that it matches up with what we've got going on with the get method. So then we can have a get extern method. We'll take a context, a type name, and an ID, and it'll do the same thing that this does. It will get the extern type, and then it will do, oh yeah, sorry, this is get extern field. Then that does field equals type dot fields, and then find one where field name matches the identifier. And then we can import reference the field. The idea being we can separate out how we handle the case where we do find the type locally from the case where it's an extern type. So we don't need that fail with anymore because that's going to happen up here when we call get extern type. So what we'll do is map try find where if we find map try find context libraries type. So if we found the type, we do something. If we haven't found it, then we do get extern field in the context for the type name for the ID, which will either find it or throw. Then in the case where it's sum, we want to do this bit. But we don't need to import reference anymore. So we just do option default with. So what that's going to hopefully be doing is looking up on the type that we're building locally to try and find a field. And if it finds one, we'll just return it. If not, then we'll build a new field definition, add it on to the type here. Export equals. Oh, yeah, so if it is exported, we have to add an attribute on it. And then we say new field, field reference. Yeah, well, that's what the cast's for, right? Is it? Or do we need to? Do we need that import reference? Let's just add it back in. Anyway, saying we're going to end up with a field definition in either case. So I think what we actually want to do is move that here to field reference. We can switch the way that we do the predicate like this so that we can inline the predicate. One day I will stop putting 2 equals when I write in F#. The day is not today. think that's good. I think that should match up with what we want. So we try and find the type in our local list of libraries. So this is the thing that we're building for the current assembly. If we find the type, we make sure that there's a field definition on it. So that means that we will add the field definition if it's not there. And then we cast it up to field reference. If we don't find it in our local list of libraries we're supposed to be building, then we call getExtern field, which will look in the external types and call import reference on the field for us. So we end up importing references to external types. We're getting rid of the import reference stuff for the local types, and we're separating out referencing external things, which now looks the same for both fields and methods, from building up the local stuff, which is done only in one place. Look at that. The tests. They're green. So this is going to be separate external types from internal libraries. Types we are building have properties added when referenced. External types are now handled the same for method lookup and field lookup. So that's unify imported methods and properties. I'm gonna move on to the second half here. So let me just find a terminal and I'll make it bigger. That's not how you make it bigger. That's how you make it bigger. So at the moment, if we are in our repository, we can do we can run the compiler. Go .NET test, which is gonna run our spec test, which is gonna run the compiler over all those specs, and we'll just end up with a load of DLLs, which is what we want. Each one of these is going to be compiled against the .NET 5 target framework, because our compiler here, Feersum, is here in Feersum bin debug net 5. And when it looks for the MS core lib, which it does in built-ins, core lib, where do we do that? There's some, yeah, we've got a hard-coded path, but the hard-coded path is based on type of object.assembly.location. So this is picking the path on disk of the core lib, which corresponds to the current runtime that the compiler is in. And that means that when we build things, if we have a look in spec bin, we've got all of our compilation outputs. So say we wanted to do .NET spec bin tail DLL. I assume that's what it's supposed to print out. So I've not actually had a look at what the tail call is. Spec tail.cm. Oh, yes, this is the whole ping pong thing. So we're expecting it to basically decrement a value. So it do ping and pong. So ping calls pong, pong checks if the value is greater than 0. No. Checks if 0 is greater than x. So if x is negative, we return it. Otherwise, we call back to ping and decrement it, and that's why we end up with -1 because it's the first negative number. Great. Then an or1 is just checking to make sure that this nested chain of like and, or, if, and t is tail recursive, which it should be. And we're ending up with t, which I mean, I assume is good because tests are all passing, which means that it hasn't changed. So the plan here is that I can run that, but I have other runtimes installed, namely mono, bin tail.dll is not happy. And the reason why is because when we emitted that assembly, all of our metadata references are to the system runtime core lib. Mono is .NET framework, so Mono's expecting our references to things like object and system.func and stuff to be in MS core lib, whereas we're actually emitting them with references to system runtime, I think. So what can we have a look at in the output? So I guess a good way to have a look at the differences here is if we create a new project in a new folder. If we cd into there, oh no, cd test, that's it, right? Remember how to Linux. And then we do .NET new console. We'll end up with a new C# project. And if we bat program, it's just a hello world. If we do .NET build here, we'll end up with .NET producing an assembly. Then we can do .NET on bin debug net5 test. Test it out. Hello world. And if we have a look at IL spy, show the IL for that last one, we'll see that the main references system console right line. Is there a way that we can see where it's imported? I'm just going to also make a build props file, because I'm noticing that we were ending up with all of the Git version information in there as well. We don't actually want any of that. So if we just add what happens is that when .NET build is run, it looks in the current directory and then walks up the path until it finds a directory.build.props file and then imports that. So just by making an empty one, we'll get rid of all of that build output. And now we should be able to .NET build and see fewer things in IL spy. Nope, that did not work. Why did that not work? Have I misspelt directory.build.props? That was bad. I keep on accidentally trying to press the wrong. Okay, right. Well, I was smart. I just cleaned up my projects, but just done it. Done a new console, the whole thing again. And we'll just edit this to get rid of the global MS build. It's going to be really small for you, but trust me. .NET restore again. Show IL bin debug net5 test DLL. Please have got rid of. Yeah, there we go. So test program extends system runtime system object. If we then do mono that path, interesting, it works. Why does that work? Why does ours not? I mean, this has to be to do with. This has to be to do with. So this says extend system runtime. So I've got all the assembly attributes. We've got, like debuggable. We've got our assembly. This is it, the extern declarations. So you have an extern declaration for system console of version 5 and system runtime. So why was Mono able to use that? That seems nonsense. Why is it not able to use ours? So let's run monodis on ours as well. So that's going to be up one level spec bin. We're going to do hello because hello was one of the simplest ones. Let's just make this full screen. So hello has an extern declaration for core lib, system private core lib, 3 for net standard. Could it be our library? The core scheme library? Don't know. Can .NET run that? Can Mono run that? No. So it's in main. File not found exception. Runtime method info is defined. Attribute is defined. Custom attribute extensions is defined. Can't find custom attribute constructor. Due to could not load file or assembly system private core lib. So our library did an assembly extern for corelib, and then we're using corelib debuggable attribute. Okay, so that's where we're different, whereas up here we have system runtime and system console, and the debuggable attribute, pretty certain we had a debuggable attribute on this. Yeah, here is from corelib, not okay. I wonder if we did a release build, would our of hello, would that work? So let's cd one directory further up, and if we run .NET run no source src Feersum, so run our compiler, and we'll say dash configuration release spec hello spec bin. This will hopefully, right? Yeah. You can't find configuration release. Is that not the right? It's not the right one. What is the command line? No, capital C. So if we create a release build, we won't have a ref. Oh yeah, get rid of the help. And we could probably have done .NET run -- no build to make this whole thing faster. No, could not find file -- configuration. Yeah, one. Then, if I do mono dis on that, bin hello.dll, and that's the wrong thing because we didn't tell it to write out hello.dll. We told it to create an executable, so it will have created hello.exe. But let's just make sure. Actually, well, go on. Let's do monodis on hello.exe. This should hopefully tell us. So we have an extern for corelib, private corelib. I think this is the key here. We're having like an extern for system private corelib because we're referencing that for our object type, whereas the one that was built by .NET Build referenced it just via MS corelib, which meant that everything, or it referenced it via system runtime, which both of them just end up being like a bunch of type, what are they called? Basically re-exporting all the types. They're all just type aliases, and yeah, could not load file or assembly. This is where mono is going to be going wrong. It can't find, when we ask mono to run it, it can't find func because we're getting it out of private corelib. So let's edit. So yeah, if I do mono on this, it's still going to fail because but it's going to fail at a different place. Nope. It's still complaining about an attribute. Anyway, the key point being we are referencing the wrong assemblies. Because, well, there's three things going on here. So if I do .NET list SDKs, this is all of the .NET SDKs that I have installed. So if I have, which is currently only 50206, if I do .NET-info, this is the SDKs and runtimes that I have installed. So when I do .NET build, what's going to happen is that when .NET build is compiling that C#, it's going to build an assembly that references something out of the SDK. When I then run that, the .NET 5 runtime, which is probably going to be the .NET Core App 509, which I have installed, is going to use an assembly out of here, which is instead of SDK, it's shared .NET Core App. It's going to use a library out of here to actually run it. So at runtime, although object was built using a reference to something out of here, the runtime will use an instance of a type out of an assembly in here. When we run our compiler, the same thing's happening. So F# and all the rest of that stuff will be referencing a corelib out of this runtime folder, which means that when we then compile, we're again compiling against that specific object out of the runtime folder. So let's have a look at what we have in user lib64 .NET SDK DK. So we have only got one. So when earlier we list SDKs, you can see the SDK version matches up with the folder name. So the SDK, what have we got in here? Let's do a -L. Whoop. Control A. ls-l on that thing. And so we've got a lot of DLLs. And we've got props files. So when you're compiling C#, these C# targets will be being used by .NET Build. So we've got the build DLL. We've got, what else have we got? I think this is effectively the MS build executable. Because yeah, there's MS build DLL, the runtime config for that. We've got a copy of NuGet. So this will be the version of NuGet that MS build uses to restore things. We've got runtimes, SDKs, Sdk Resolvers. So let's have a look. Runtimes is going, what's runtimes going to be? So let's just CD to there. And then runtimes. Tree just shows you the directory tree. We probably don't need to go that far. Is that right? No, that's... L. Big L. So in here we have current, which is like a... It's got target files in for MS Build. We've got globally installed .NET tools, so things like .NET Watch, .NET User Secrets, and all the rest of that stuff. We've got the F# stuff, so that'll be the F# compiler that we're using to build our compiler. Well, no, wrong. This is the SDK, so that will be the F# SDK that our compiler is being built against. We've got Roslyn, which is going to be the C# and VB stuff. Oh no, yeah, these are the actual compilers that are being used to compile it. And then we've got SDKs. So I think so the SDK resolvers, this is MS Build stuff that allows you to extend CS projects and things. So when you have a look at a CS proj, you see it's a project SDK equals, and then this is an SDK identifier, and it is resolved by one of these SDK resolvers. So we have this one, the workload MS Build SDK resolver, which when you do things like Microsoft.NET.SDK is what's looking in here in the SDKs folder for this folder and using that. So what it does is it uses the props files out of that. So if we do an ls on SDKs and Microsoft Net SDK, in here we have SDK.targets. So we have SDK.props and SDK.targets. And they're basically what happens is that MS Build treats your SDK equals as please put an import at the top for my props and input at the bottom for my target. I think that's the way around it goes. And we also have another SDK resolver, which is what hopefully we will be able to use in the future, which is the NuGet SDK resolver. So you'd be able to put an SDK identifier and MS Build would download it from NuGet. So I guess what we probably want to do is if we just open code in there. Don't trust the author later for the updates. So we've got the SDK props file, which is looking for targets, common props, the targets. Somewhere or other, we must eventually set the framework reference path. And that'll tell us where the reference assemblies are supposed to be. And then we can just hard code that for the time being. Import NuGet build task pack targets from SDK. Before common. No, this is basically all deferring to that Microsoft.NET SDK target stuff, isn't it? Which is here. Basically, the SDK folder is just a stub that's importing this stuff one level further up. So we've got Don't care about code style. Don't care about analyzers. We've got the targets. This is looking like it's right. And we have tools. So we got, this will be the actual MS build tasks for doing the compilation, the build against .NET 5 and .NET Framework. So we want SDK common, I think. And then somewhere or other, there's got to be a property definition. Let's continue looking. I suspect it's that ref folder. Or it's in the Runtimes any folder. So if we tree ref, so that's where net standard is. So you can mono this. I think this is just a full of, yeah, this is just full of type forwarders. And it's all in external in net standard. I don't know. Wow. Yeah, that's not really, you don't want to see the whole of .NET standard. We can probably head it though. Okay. Oh yeah, because I mean, there's not going to be any external decorations because this is the core lib. So it doesn't depend on anything. That's the whole point. But what was the other folder that we thought might... Let's just do an ls again. Runtimes. So runtimes any... Okay, so that's a copy of system drawing. So the question is, could we use that .NET standard as a reference assembly? To be able to do that, we need to be able to like compile using a different reference assembly. We need to get rid of these hard-coded locations. So let's add we can get rid of all of our test stuff because there's nothing interesting going on there. And let's hello, are you? Let's just go and add the files directly. I'm not sure what's up with Inide. I guess we want something like a targets. So targets.fs is going to have to, well, we're going to need it before compile. That's all we really know. For the time being. And then targets.fs. No. What we'll do is move these two into here, and we'll have a type target. I mean, target framework, target info. Sounds better. Then people don't get it confused. So target info is going to have we'll call it Lisp core location type string and ms core lib. I don't really know how to capitalize that. I think it should be core lib like that. So our type target info is going to be resolved target path. We can make this a namespace, I think, and have a module target resolve. Put them in here. So resolve target paths for reference assemblies. So it's got ours and it's got the core lib in there. Module methods for locating and SDK. Just not bother documenting it because we don't really know what it's going to end up being yet. And we can do, so we can do let public target resolve get or target resolve from current runtime. Then we can do Lisp core location equals for assembly location ms core lib location ms core lib assembly location. And this is return or yeah, return target info current running process. What are you upset about? Put copy and paste. Now, what have we broken? So built-ins is not happy because what we can do here is we can take a target, and here we can also take a target, and then that becomes target dot. Is this correct? This means that targets need to come before built-ins. I mean, it's probably fine. Not again. And that wants to be no. Like that. Targets comes before built-ins, and we can do target Lisp core location. And MS core lib location. Target info. Probably just open targets at the top. So that's happy. Now, what we need to fix is going to be compile, which is now going to be upset all the way down here where it's doing the so omit could pass the targets in here, couldn't we? Then that becomes target. Oh no, core types needs to be here target, so that core types is resolved. So that fixes that bit. Load core signatures. Compile is going to need to do something to get to targets. Target equals target resolve. Yep. Target resolve from current runtime. Then we can pass that in here. Load core signatures. And then pass it down here. And then everything should work the same way it used to. Which it does. And I guess what we want to do here is in compilation. So we should probably commit what we've got here. So introduce paths to our reference assemblies. So if we've got the reference assemblies in the target info type, we want to go to our options, which is our compilation option structure, and we want to add a new optional thing, which is going to be target framework. What do we want? For the time being, we probably just want to have like a core lib path or something. Or MS core path. And this is going to be of type string option. Then we will default it to none. MS core path is none. And where's this called from? This is kind of useless because we could just do what's being done below. Like spec tests, XX with references. So like that could be. What is references here? Is references a list? It is a list, so we could just do options is compilation options create with references like that. Is that still happy? Same thing here. We can do an objects literal like this with references. Whoops. Really doing that a lot today. Args get results reference list of seek. And then boom. Now in program, let's add a compilation option so that we can we want a compilation option so that we can specify the core lib path, which can be core lib path of string. Then before reference. Oh, these are not in the same order. We should probably make them in the same order so that it's easier. So version first, then configuration, then output type, then core lib path, then reference, then output, then sources. So R1 came after output type. Core lib path is location of ms core lib.dll or system.runtime DLL. Then down here, when we build up that compilation options, we will also do with core lib path. And then we want to do args.get result core lib path. What is this going to produce? Do we have a try get result? We do. What does that return? You sure? Oh, we call it ms core path, didn't we? Just a little bit of extra space. So if this builds, we can try building some of our scheme using the actual reference assembly rather than the real assembly. Which is going to, well, we'll do it from here. So, oh no, we won't. We'll do it from the VS Code bash prompt because it's already in the right direction. So if we do .NET run no build project R compiler, let's just check the compilation option. Yes, we do have core lib path. So we do core lib path, which is going to be slash where was it? User lib64 like this. I'm gonna copy and paste because we don't have time for the mistakes. Ref ms core lib, and we will compile spec bin, oh no, spec hello, and output to spec bin hello DLL. And then we monodis that. We're referencing ms core lib system object. We're still referencing private core. We don't actually do anything with that core lib path. So in compile, we want to say if we got given a core lib path, ms core path. So if we got one, we want to call like something that doesn't yet exist. And if we didn't, then we want to resolve from current runtime, which is going to be target resolve from core lib path. Let's just copy that method name so that we've got it. No, it must be public. We're just going to use our local copy of Suri for assembly for the time being, but we'll set the core library location to path. Build it again. Mono should be okay with our build of Sarifa because our build of Sarifa is built against .NET Standard. Ooh, we're not happy about that. What are we not happy about? Yeah, this is probably because it's a reference assembly that's got a bunch of type forwarders in it. So what we're going to try for the time being is just going against .NET Standard instead. Okay, and now we do monodis. We can just do the last monodis. We are doing memo's calllib system object system private calllib object c to what? This isn't. Still. So we're doing system private core lib for some reason. And it seems to be. So undefined get instance is fine. The place where we get broken class seems to be that we're referencing system private core lib. For that function type. So let's do the same thing and see where we end up if we are in the debugger. So spec, oh, we want to add that calllib path on, don't we? To the run settings. And that's going to be launch JSON. Feersum compile, and then just paste that in. Do a little bit of JSONification. Good. Then if we compile spec hello, we'll hopefully hit that breakpoint and find out why we're generating a reference to private calllib when we thought that all of our types were coming from Yeah, so MS core lib location is that location. So what about the built-ins? Did I put a breakpoint in the wrong place? Oh no, I've got a breakpoint here in built-in, so we're not actually resolved the core types yet. What have we, where are we? Oh, I see. So yeah, when we actually try and use a scope, so bind is taking all libs. Okay, yeah, so we haven't called import core yet, so we're actually only scanned the assemblies for... We only scanned the assemblies for the library declarations. We haven't actually done anything interesting. And now we're going to have a look at... This is the bit where we're doing the func lookup. So what do we have as the external assemblies? Serifa and .NET Standard. I mean, it might also potentially be that it might be that Mono just can't run based on our reference to system func. We didn't ever actually use system func for the like demo C# application either, so it'll be interesting to see what happens if we compile that against the mono reference assemblies, whether that would even work. So we got func invoke, and then that is system func. Blah, declaring type is system func system object, right? And generic arguments is but then metadata token is null. I think that's probably because it's not been import referenced or anything. I don't know. Oh no, wait. What is going on here? Why does this end up being private? Why does this end up being from private core lib? Let's have a look at what module it's in. So namespace scope. Scope is a metadata scope which looks like it says private core lib. Is it just that the type in .NET Standard for func is in system private core lib? Can I go back? I wonder if I wonder if the original type that we got is good, but it's our funkiness for generating the references to the method that's broken. So this is the original type. This is the functick2 that we looked up those methods off. And this has somewhere a module in system private core lib. Don't know. how about we try compiling using the mono reference assembly. So mono should be in user lib mono. And then we will go against 471, I guess. 7.1. What else have we got in here? So we got system. Let's just take that path and get the big console out. Oh no. LS. Did I not copy that? Oh, I cut it. So yeah. User lib mono. And then it was 4.7.1 API. And in here we have system.net. Yeah, and then ms corelib. So let's try using that as a corelib path. Copy. Let's go back to our last compile. Oh yeah, we didn't do the compile in here, did we? So get rid of that. Do here in bash. Corelib path. There. It's worked. Can I do .NET spec in hello.dll? That works. Mono spec in. No. Why though? Still referencing private corelib. And it's version 5, so it's definitely somehow or other we're still generating a reference. Let's just make sure we've got no compilation outputs. And we're saying corelib path is lib mono. You got system private corelib all over the place. And it is here, extern 5. So ms corelib's at 4, but why are we still generating references to things that are system private corelib? I mean, it must be to do with this, either make instance type, make generic instance type, which basically copies the arguments in as generic instance arguments. So I doubt it's that. Or it's the dubiousness of this. So how about we separate out let func type. We'll separate each step in the chain. I will see when it ends up being wrong. And just for lulz, we will use the mono launch path, which I think I might still have copied. Spec hello. So yeah, we don't need a breakpoint here. We're happy that the types and stuff go there. What we do want to see is what we've got two libraries loaded. We have MS-Corlib, which has a bunch of types, and Srif. When we look up system.func, what do we find? We find system.func but could it be when we're converting when we call get type, we're going to walk through the main module types and try and find it. Could it be that we're picking it out of the wrong assembly? Or could it be to do with when we call import reference? Because what I do notice is that, so the type name is system.func tit2, and the namespace is system, but the module is this Lisp module. So it's like this is the copy of the type that we've imported. Is that a bad thing? Because I bet the main, I bet in here, the metadata resolver let's go look in dot bin. Yeah. I think we've already gone wrong here because I think that by this being the copy of system func that we've import referenced into our assembly, when we then call make host instance blah blah blah, we're all creating references to that. And the core lib for our assembly is probably going to end up being wrong somehow or other. When did we generate this? Lisp assembly. Assembly definition. We made this from an assembly name somewhere. Load core types. It's going to be in the compiler somewhere. And compile. Output stream. Emit. Oh, yeah, it must have been an emit. Because, yes, so we create a module. We got the assembly name, module kind console. We're good there. Module name. Is it? How do we specify? Is it this module parameters? Get rid of the debugging out, I think. Module parameters. So it's just referring to module definition, create module. Let's go grab the actual source code again off. So that's .NET. No, this is mono Cecil. Make it bigger. And it is module parameters, which is kind of here. Public sealed class module parameters. So we have a name. We have the which we set based on the module name. Parameters kind timestamp. Oh, cool. Runtime. Architecture. I wonder if these are somehow being defaulted based on the current runtime. Metadata resolver, assembly resolver. Where is the, so we're finding out where it's used. What about where is class module parameters? So runtime, do we default that somewhere? Yes, get current runtime. What does pass runtime do? So it looks like the runtime I don't think that's the right thing. I don't think that, because it looks like target runtime only has support for net 4, net 1, net 2. So this is like really old stuff. And everyone else goes down this code path, case 4, and gets runtime net 40. Yeah. So back in the get type stuff in the binder, sorry, in the built-ins, rename this to get imported type. Then we can also move this into get type name. She's going to return the actual type definition, and then we can turn it into a reference with get imported. What happens if we do get type here? And get the raw type rather than the type reference. Is it even going to compile is the first question. People one says, hi, when you say scheme, do you mean the Lisp dialect? Yes, I do mean the Lisp dialect. It's not a fourth dialect. Is Visual Studio Code really more comfortable for you than Visual Studio? 100% yes. For a start, we're on Linux here, so Visual Studio isn't even an option. But just in my day-to-day life, I use VS Code. I can't deal with, well, I mean, I can use Visual Studio if I need to, but it just feels clunky. I'd much rather use code. Not to say that other people aren't allowed to use Visual Studio, but it's not really for me. So everyone says, I notice you're under Linux. Yep, this is Fedora 34. Eagerly awaiting 35 when we get GNOME 41 and all the rest of that shiny stuff. So we have func. Where's the declaring type? No. Where's the assembly? Type definition does not contain. How about module? Okay, so we are now from MS Corelib. So when I call make instance generic, what happens then? Still MS Corelib. Then I call resolve. Still MS Corelib. Now this is the interesting one. If we create the ctor, func ctor. We have system void, system func tick2, system object array, system object, blah blah. But what type? So the module definition is Lisp module, I think. Have we still gone wrong? Let's find out what the output ends up being. So get the terminal back up and we'll have a look. ls spec bin. So we've got hello.exe. I want to know which one's newer. Hello.exe is from 1243, so it's that one. So if I do mono dis on that, maybe we'll have some more questions. Question, is this your first compiler? It is not my first compiler. What is your biggest difficulty in the overall chain of lex, parse, rewrite, reduce? I guess, like, each one of my compilers, there's been different points where I focused on. So, like, I've definitely had a phase where I was very into, like, getting the parsing down and that kind of stuff. I think the big thing for this compiler has been the work on like captures and closures and stuff like that, because that was something I hadn't really tackled before. I guess the one big thing in compilers that I've not tackled is that I am omitting. I've done compilers that target bytecode. I've done compilers that target things like .NET-IL. I've done ones that emit native code using things like LLVM, but I've never done register allocation or any of that kind of stuff. Have I heard of RPL or HP48? Nope, I haven't. I'm reasonably familiar with SIL. So, yeah, the func object ctor stuff I was showing you is so this thing here that we're building up, we're using monoreflection to pull out method and type references that we use when we are emitting the end assembly. And these three here, func object type, object ctor, and object and invoke, are used for the representation of things that you can call in Scheme. So because we box everything, so like Scheme numbers are represented as box doubles, Scheme methods are represented as boxed funcs, and we use object array object as the signature. So the array is the input arguments, and then what happens is that every single time you write a function, so I'll go find some Scheme to talk over. Every time you define a function, so like append in this case, we will emit an actual function which takes two arguments, and we'll emit what we call a func, which has the same signature as that object array object, and it contains the code to unpack the arguments and check that the argument count matches. And that gets a little bit more complex where you are actually using REST parameters like this. So in that case, pivot is a positional argument, and then anything else you pass goes into list. So we have to take the array and turn it into a list, which is a linked list of cons pair types. Is scheme commonly executed as threaded code? So, I mean, the way that the scheme specification is defined, the idea is that functions don't actually return values. Functions call a continuation with a value at the end. And so you have this continuation that's passed all the way down, and you get some scheme implementations that actually do implement it like that. But the problem there is that you have to move each scope onto a stack. Yeah, so they're not stack based. You have to move each scope. Sorry. The scope stack becomes just objects in the heap that are maybe related to each other. You have to GC the scopes as well as everything else. What I'm doing is I'm supporting a subset of scheme where we can actually treat function returns like you would expect in .NET. And so we do have a normal stack, and I'm going to be able to support some of the behavior of continuations using .NET exceptions, because continuations can be used to do like non-local returns, and you can do the same thing by throwing an exception and catching it. There's some tricks you can do there, and there are other scheme compilers that do the same kind of thing. I don't think it should be a major limitation. When it comes to types, yeah, like every object in scheme does have types, it's just not statically typed, which is yeah, that's the problem. And it means that, so like when we hear, when we see things like a reference to the function null ? We don't actually know that it's a function that takes a list and returns the bool. We don't actually even know the arity of it, and it could be reassigned at any one point in time. It's all very abstract. So there's extra, like, it's not necessarily going to be the most efficient .NET code, but it works. What I'm currently battling with was trying to get the compiler to... okay, right, now, see, this is what we want. We're now referencing ms corelib system func, not someone with a bad token that Mono wasn't happy about, which might mean that Mono spec bin hello. Oh, damn it. I mean, we're close. Something else is referencing corelib. In the constructor. System exception. So it looks like system exception and system objects CTOR, and I suspect many more will actually are importing badly. And that is done by... so system exception is there. I don't see object. So that was when we did it's gonna be in the IL helpers, because that was the object. Do we just not want to call import reference there? Let's clear out the output folder again. And recompile. But we will build this time. Corelib path is monos, corelib path. Mabel one says, this is appreciably involved. I am envious. It says Lisp program. Yeah, so Lisp program, I think, is the... we fabricate a type, because obviously all the stuff in your Lisp, in your scheme file is at the root level. We fabricate a library type to wrap it all in, because .NET needs an object. What has gone wrong here? System void is declared in another module and needs to be imported. Yeah, but, well, when we did import reference like that, we ended up with the constructor being tied to private corelib, which was not really what we wanted. But it's going to refuse to emit if we don't. Let's just try again. See if like rolling that back has fixed it. Oh, yeah, it wants to be DLL. Well, this is actually the environments constructor, so maybe the other objects constructor is fine. It's not fine. It's referencing corelib. But if we don't import reference, do we need to import reference the type, not the method? What did we manage to do down here that made this still reference it via corelib? Maybe that's what we need to have a look at. So we're using type system object, and we're calling resolve and get constructors on it to find the methods. When in built-ins for func type, oh, we're still calling import reference, okay, but we're basically calling get type, which is going to pick it out of the is going to return us a type definition. We're calling make generic to add the generic arguments on, which is then going to still give us, which is a generic instance type. We're calling resolve to get a type definition again. And then, wait, why are we calling make generic instance type twice? Surely functie can just be functie. Because I'm wondering if make generic instance type there is somehow undoing the call to resolve. So is this gonna import, is this gonna do something bad? And end up with broken stuff again. Table 1 says unless we're scheme and then a bunch of scheme code. RPL represents it. Well, I mean, it's probably best if I show you. It's sys RPL. So we're saying like 1 minus 2 times 3 becomes 1, 2. Oh, okay. So is this Polish notation? Yeah. And then percent 1% 2 minus. There's no 3 there. That's what I don't understand. Is that a mistake that you've made? Oh, reverse Polish Lisp. Okay, I understand. So it's a mixture of Lisp and reverse Polish notation, which is just another way of writing. So normally when you do arithmetic operations, a normal arithmetic operation would be like 1 plus 2, and then reverse Polish would be 1, 2 plus, where you're effectively treating it as a stack. I think some old calculators used to use that notation. And I guess since that's reverse Polish notation, does that mean that plus 1, 2 is Polish notation? That's a question. Level 1 says most Hewlett-Packard ones prefix notation is called Polish. Well, that's good to know. Just in case you ever need to write mathematical operations in prefix. Reverse Polish is good because you can evaluate it using a stack machine quite nicely, which I assume is why they used it in compilers. Sorry, in calculators. Whereas I guess the way modern calculators work, you'd have to do you have like, wait, I don't know, there must be several different stacks involved because there'd have to be one for all the brackety stuff and one for like keeping track of your current accumulator versus the thing that they're typing in. Anyway, that's a sidetrack. Have we gone back to referencing the wrong thing now? No, it's still system func. So what did we actually change? In built-ins, I changed it down here so we don't call make instance generic again, and it still seems to work, maybe? So system func. So we do need, it's the resolve call that's the problem. The resolve call is bringing it. That's weird. I don't understand. Don't understand monosessile enough here. Mabel 1 says, basically, yes, compilers 2, you were not strictly wrong, which is nice. So, why? I mean, let's put this all back together into a single pipeline, because we know that this now works better, for some value of better. So yeah, I wanted to be make generic instance type dot resolve. Can I do it like this? I can't even remember what I had it like before. It's basically the same, but without the import reference. Is it? Or is it even just like, oh no, it was just all, it's just one big line. Okay. We can just revert that because we haven't actually changed that. We've just changed that what get type was. What on earth are you doing? There we go. And then hopefully this is still going to generate a nice DLL that references system func properly. But we need to work out why, like, and we can do that if we can work out how for IL helpers, I'm sure we'll be able to apply the same fix. So what does import reference do? Like it, we're not allowed in monosessile to emit code if we don't call import reference to turn the type definition in one assembly into a type reference in another assembly. But the problem seems to be that import reference ends up changing it from being a reference to a type in corelib to a reference to a type in system.runtime. So field reference is it No, that's not what we want. That's the interface. Is there actually an implementation? Probably in here. Probably in that. Is it in import? We're in import, so it's not. It's unless it is. Unless it is, no. So you got a metadata importer and a reflection importer. Okay, so if we get a system reflection assembly or an assembly name or a type, then it's going to call this is the okay system reflection field info method base. So that's if we're doing it via system reflection. But what about if we're doing it with mono reflection? So we've got an assembly name reference. Doesn't seem to be there. There's a little bit of pink down here. Yes, okay, so we have a type reference and we want to just gonna yeah, all right, so it calls import type on the declaring type and it creates a new method reference. It's got the same name, but the declaring type is the imported one. Calling convention is the same. You've got generic instance parameters, it copies them over. It imports the return type. And then if the method has parameters, it goes through each parameter and adds a parameter definition where it's imported the type of the parameter. I mean, that all sounds kind of acceptable. I guess the question is, what does import type do? Could it be process primitive type reference? Try get primitive data. What is primitive value types? So I suspect this is okay. So it's a dictionary of just basic things. So I don't think that's where we were going wrong. What's module here? Oh, okay, so it's the metadata from. Okay, so it attaches it to the current module, and is that where we're going wrong? Because the module definition, when that kicked off, we had yeah. I don't know. What I'm going to do is I'm going to take a quick break and get some coffee and come back. So stick around for 5. See you. I'm back and we have coffee. So hopefully this should become more doable. Maybe the tests is a good place to look. Like, this is just testing reading some known modules. Let's go back to say it's import reference we're confused about. Import Import Cecil tests, because we're doing Cecil imports. Let's get this bigger. Compile func string test compilation services, eh? This is doing a method definition. It's doing module import reference. So it's creating a new method, adding it to the type. So don't really understand. This is import Cecil types, but I see a ton of like type of string.get method. There's a generic example here. This is taking their field where the name is field. So really what we want to do is call system func. Let's have a look. Where do we like, so the system func stuff is all working now. So if you put a breakpoint here and try and do the compile again for spec hello, we're using the call path from mono. So we'd hope that I suppose the problem here is that we're using the, is it the problem? Because like asm, the object constructor here is going to be, is going to end up in the wrong module. Somehow or other. So type system object at the moment. Well, you see this, yeah, at the moment it's our system object is for, it is the one that's imported into our module. So yeah, we've got the metadata scope for core library. Is the problem that when we then call .resolve, that's where we end up with the copy from. So this time we're getting a type reference. So maybe this isn't import reference stuff at all. Maybe this is the resolve calls that are the problem. Yeah, so look, now the metadata scope system private core lib. Whereas, does this have a metadata scope? Oh, the token's empty. Yeah. So I think when we create the what do we need to do here? So where anytime we load or create an assembly, which is in the built-ins, is it? Thought it was. Assembly definition. Pass in reader parameters. I think it's probably going to be enough to have the target assembly, when we pass the target assembly in the compiler, have assembly definition. When we create this, if we have like a reader module params, module, what was, so we have create assembly. There was an overload of this that took module parameters. I think if we make module parameters, key is that, well, get current runtimes probably fine for the time being, because we know it's just going to always end up as the same thing. And then the metadata import provider is what we're going to want to set. So we'll set the target kind. We set that to console, just like we used to do before. And don't know. I think maybe it's this metadata resolver. So an I metadata resolver, we have, so like a base one, metadata resolver. Or do we just need an assembly resolver? We probably want an assembly resolver. Base test fixture. So we have base assembly resolver. And if we don't match hold words, well, so we've got the base one, and all right, well, we are in base assembly resolver. All right, I suppose I'll allow it. Default assembly resolver. So the default assembly resolver has a cache, and I guess we can do the same thing. We'll have like a custom assembly resolver. What is abstract in base assembly resolver? Nothing other than the directories to look in. Is there a way to clear all of those directories? We are on .NET Core, so there's not going to be a git core lib thing. I think what's probably happening is that the assembly resolver, I mean, the compiler is going to be running from here, and then the assembly resolver is going to try and resolve from here. And then if we're on, it's going to search trusted platform assemblies. File names of available trusted platform assemblies to their full paths. And that starts with create trusted platform assembly map. So trusted platform assemblies from the current app domain. So it's that bit that's the problem. So maybe if we add directory, can we add search directory? We might not need to define our own type for this, because it might be that adding the directory of the MS core lib is enough. So if we do assembly resolver, can I do add? No, I have to do default assembly resolver to create a new one. That wants to be module params. Now we're building it up. That wants to be a resolver. Yeah, so how about just use resolver. Sure. What's new? Then we can say resolver dot add search directory path get directory name targets dot ms core lib. Maybe So we'll see if this passes the tests. Okay, so we're still generating code that works, but does our custom compile command down here does this? Work. So that still works. And then if we do mono dis spec in hello, call instance void object ctor. Okay. Call it double. Core lib diagnostics. This is looking a lot better. I'm not seeing any of those nasty you couldn't resolve this metadata token things, and we have. Apparently, for some reason, 2 externs from MS Core lib. Or extern for Sarifa net standard, which I assume is because Sarifa references it. I don't know. I can't see. Can't see any net standard paths. Let's try it out. Boom. Well, I'm impressed with that. Does .NET run it? Let's see. Can the .NET 5 runtime run this .NET framework binary? It can. So we have an assembly definition. We have a CIL assembly which is runnable on both. So we compiled this against the reference assemblies from Mono. Yeah. I'm just wondering about whether some things are going to be broken here. So how about we try the REPL out, because that is most likely to end up broken. So .NET run project source. So if you just don't provide it with any parameters, we will end up in the REPL, hopefully. And if I define foo world as display hello display foo new line, and then call it and what has gone wrong there? Oh, I printed out foo instead of printing out world. Hello world, maybe some spaces. The key being though, it all appears to work. So let's go through what we've managed to achieve here. We've got the core lib path stuff. Probably don't want to check that in. But yeah, let's discard that for the time being. We've got built-ins, which is, so we now have the distinction between get imported type and get resolved type. Which I'm wondering with our recent change to the metadata resolution whether or not we need that. We call get imported type for const parent value type. So that's good. We now specify an assembly resolver when we create the assembly, so that when we're import referencing things, we end up looking the types up from the correct place, because previously what was happening was mono Cecil was resolving the assembly, so resolving the type references or method references to actually method definitions by trying to look up the assemblies when types were imported, but it was looking up the ones for our current runtime. So I fixed that now. We now have this MS core path, and if we have one provided, we use target resolve from MS core lib path, otherwise we do from current runtime. We have the MS core lib path in compilation options, and we got rid of the needless mutator function thing. We've got core lib path as a command line parameter and just general tidyings up. We've got target from MS core lib path so that we can actually pass it in, and the spec tests use an object, whatever they're called, object literal, to specify compilation options. So support compiling, yeah, that word, compiling custom core lib add a comply flag to passing core library location. If one is provided, then load core types from there rather than current runtimes core library. Picks up assembly type resolution, so references to core types are loaded from, or not loaded from, the current runtimes copy of ms core lib. This, well, this means compiler can target other runtimes such as I guess. I wonder. So if we go, if we go into the specs, could we tweak this so that we run the spec tests on both, using both .NET and Mono? So, I mean, running it is kind of simple enough. So you do, so doing .NET, the assembly path, we do Mono, the assembly path. We want to do the same thing with standard input and output. Wait for exit. So I think there, let's have host because that's technically what these things are called. And then what's broken? So run example. So XC path. Let's make compile file. Oh no, wait a second. Compile file is actually, yeah, we can't. Can't just tweak that, but we can at least make the output what we really want is to do this after we've made the compilation options. Because we can do path.join options configuration. Is it just path.combine? Yeah, I think. Yeah, we need to make this an array. Is this really better? Spec bin, that. So I guess like let's output name should probably be the path change extension bit. Which would be S options dot default extension, might as well. So we take the output name and then we build a path from it, which we can do like this. String, right? So that's a string. Yeah. That's a string. That's a string. Oh, yeah, because this needs to be F# array. It's going to be output name. So if I run the test task now, well, that's embarrassing. This is the point where apparently a telecoms engineer has accidentally cut through or damaged my internet connection. But I think we had successfully demonstrated compiling for a different target framework for Mono, and I'll just wrap it up. So thanks for watching, and I'll see you next time.